Hello friends, today we are going to learn about some basic and essential concepts of number system. You all must have studied about numbers in your previous classes. You must have learned what are the numbers, how we can count. Suppose I will ask you to tell me the number of students present in another class. So what you will do, you will go and start counting 1, 2, 3 and so on. These and then you will tell me the exact number of students present in the class. These counting numbers are called natural numbers. Okay, so today our topic is real numbers. What is a number system? This is the basic and essential concepts of number system. What is real number? So today we will discuss about what is real number. Okay. So whenever you will count, you will start counting from 1, 2, 3, 4 and so on. So suppose I will ask you to go and find the number of students present in another class. What you will do, you will go and start counting and then tell me the exact number of students present in the class. So you will start counting like 1, 2, 3, 4 and so on. And so on. So these counting numbers are called natural numbers. We have given a term that is called natural number. So natural number starts from 1 and goes up to infinity. We denote natural number by n, capital N. The letter N comes from the word natural. Okay, so these are natural numbers. Can you tell me what is the least natural number? Yes, least natural number is 1. Now, can you tell me what is the greatest natural number? No, we cannot. Because whenever we think of a natural number which is greater, when we add 1 to it, then we will find another greater number. So, we cannot identify the greatest natural number. Now, think about this. All natural numbers are sufficient to express all mathematical terms. Can you think? Let's get an example to understand. Suppose we have a basket. Okay. And in this basket we have 10 fruits. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Okay, these 10 fruits we have. If I will put all the fruits outside from the basket, then what will left in the basket? When I will put all fruits outside the basket, then there will be nothing in the basket. Okay, so what is the term we have to express this nothing? We have another number which is 0. 0 is used to express this type of situation where there is nothing. Okay, so the set of 0 and all natural numbers forms a set of whole number. So 0 and all natural numbers, okay, forms a set of whole number. So we have another number which is whole number. Whole number starts from 0 and goes up to infinity. We denote whole number with the capital W. Okay, the letter W comes from the word whole. Now, can you tell me what is the least whole number? Yes, least whole number is 0. Now, can you tell me what is the greatest whole number? No, we cannot. Because whenever we think of a whole number which is greater, when we add 1 to it, we will find another greater whole number. So that's why we cannot identify greatest whole number. Now, can you see? In whole number, we have all natural numbers. Natural number starts from 1 and goes up to infinity. Okay, so we can also say all natural numbers are whole numbers. But can we say all whole numbers are natural numbers? No, because there is 0 and 0 is not a natural number. That's why all natural numbers are whole numbers, but all whole numbers are not natural numbers. Now can I rub this? We have studied natural numbers and whole numbers, but are natural numbers and whole numbers are sufficient to express all types of mathematical calculations? Let's take an example to understand. Suppose we have to subtract 9 minus 2. Then what we will get? We will get 7. And if I will tell you to subtract 9 from 2, subtract 2 minus 9, then what we will get? Are whole numbers and natural numbers are sufficient to express this type of situation? No. That's why there is another number which is called integers. Integers is a set of 0, all natural numbers and all negative of natural numbers. This form a set of integers. 0 positive natural numbers means natural numbers, 5 and so on, and here we have negative of natural numbers. This is the set of integers. Their negative number also goes up to infinity and positive number also goes up to infinity, endlessly also. And we denote integers with capital I, also with Z. Capital I, you know, the letter I comes from the word integers, but the letter Z, this letter Z comes from the word Zehlin. Zehlin. The word Zehlin is a German term which means to count. Now, can you tell me the least integers? Least integers, can you tell me? No, we cannot, because this will goes up to infinity. That's why we cannot identify the least integers. Now, can you tell me what is the greatest integers? No, we cannot also tell that, because this also goes up to infinity. Okay, that's why we cannot identify least integers and greatest integers. So integers are represented on a number line. Okay, in number line we have 0 in middle, and in right side we will take equal distance for each point. Right side we have positive, right side we have natural numbers and left side we have negative of natural numbers. It can go so on and it can also go up to infinity. So this way we represent integers on a number line. Now can I write this? Now next term we have rational number. What is rational number? Rational number is in the form of p by q, where p and q both are integers and q equals to not 0. Rational number is in the form of p by q, where p and q both are integers and q equals to not 0. रैशनल नंबर में p by q के फॉर्म में होता है ना, एंड p एंड q बोथ आर इंटीजर्स एंड q का वैल्यू क्या है, 0 नहीं हो सकता है. सो लेट्स सी अ नंबर लाइन. Here we have 0, 1, 2, 3, 4, 5. Here we have negative of natural numbers, -1, -2, -3, -4 and so on. It can goes up to infinity and there also can goes up to infinity. Okay. So let's expand this. I am expanding this 0. Here we took 0 from there and here we take 1 from here. We will expand this. Okay. So can we insert rational number between these two rational number or integers? These are also in a rational number because whenever there is nothing in denominator we can write 1. That's why these are also called rational numbers. So can we insert another rational number between these two rational numbers? Yes, we can. We will divide this into 10 equal parts. And then 10. So we have divided this in 10 equal parts. That's why we can write this 0 by 10. This is the 0 part of 10. And here we have 1 by 10, 2 by 10, 3 by 10, 4 by 10, 5 by 10, 6 by 10, 7 by 10, 8 by 10, 9 by 10 and this one is 10 by 10. From this the one came from. Okay, so these are the fractions we have. These are the rational numbers we have between two rational numbers. We can also write like this. This is 0.1. This is 0.1, 0.2. When we write in decimal, we can write this 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9 and this is 1. Now, if I will say, can we insert another rational number between these 1 by 10 and 2 by 10? So yes, we can do this. Now, can I write this? Now, we will see how we can insert a rational number between two rational numbers. Suppose we have two rational numbers a and b and we have to insert another rational number between a and b. Here we have a and here we have b. on number line. It is given that we have A and B. These are two rational numbers, and here also it's mentioned that A less than B, because A is on the left side of B. That's why we can say A is less than B, because when we go left on number line, we will find we have numbers on decreasing order, and when we go right side on number line, we will find the numbers are in increasing order. Okay, so that's why we can say A is less than B. Now by the rule of addition, we will add B on both sides. So here we have A plus B less than 2B. Okay. Now we will by the law of equality. Now by the law of equality, we will divide by 2 on both sides. So here we have A plus B by 2 less than B. 2 will be cancelled, and here we have B only. A plus B by 2 less than B. Now this we have first equation. Now again we will write A and B. Here we add A on both sides. Here we have A less than B again. Here we will add A on both sides. So here we have 2A and here we have A plus B. So by the law of equality, we will divide by 2 on either side of this. So now we have A less than A plus B by 2. So this is our equation 2. Okay. So from these two equations, we can identify that A is A less than A plus B by 2, and here we have A plus B by 2 is less than B. So we find another rational number which is A plus B by 2 between these two rational number A and B. So we can put this. Here we have A plus B by 2. So whenever we have to find a rational number between two rational number, we can add these two rational number and divide by 2. So we find another rational number here, and if we will add these two and divide it by 2, we will find another rational number here also, and we can continue this process to find more and more rational numbers. So this process we will get to know that there are lots of infinity of rational numbers between two rational numbers, and we can find many rational numbers between two rational numbers. So can I wrap this? So here we have a question: insert two rational numbers between 3 and 4. So here we have two rational numbers 3 and 4. We have to insert two more rational numbers between them. So first we will find like this: 3 plus 4 by 2, which is 7 by 2. This we call x1. And again we have seven by 2 plus 4 divided by 2. So we can write like this is multiplied by 1 by 2. So 1 by 2, here we have 2, 7 plus 8. 1 by 2 into 15 by 2, which is 15 by 4. This we call x2. So we have determined two rational numbers which we have denoted by x1 and x2 between these 3 and 4, between 3 and 4. So we can write like this: 3. Next rational number is 7 by 2. Then we have found here 15 by 4. Then we have 4. So this two rational number we have inserted between 3 and 4. Can I rub this? Now we have another question. We have to insert 50 rational numbers between 1 by 2 and 2 by 3. Okay, 50 rational numbers. Insert 50 rational number between 1 by 2 and 2 by 3. Here we have to insert 50 rational numbers. We cannot do this by the previous method, because when adding and dividing by 2, it will take too long and it's also time taking. So that's why we will use another method to find 50 rational numbers between these two rational numbers. So here we have 1 by 2 and 2 by 3. First we will take LCM of denominator 2 and 3, which will be 6. Okay, now we will change this equivalent fraction. So we will multiply by 3. Here we have 3 by 6, and next 2 by 3 also into 2 by. So here we have 4 by 6. So we have 3 by 6 and 4 by 6. Here we have to insert 50 rational numbers between these. Okay, so what we will do, we have to insert 50 rational number. That's why we will multiply this number with 51. Okay, so here we have 3 by 6, which will be multiplied by 51 in numerator and denominator both. 3 1 is 3, 5 3 is 15, 6 1 is 6, 6 5 is 30. This is equal to 1 by 2. Okay, 153 by 306 is equal to 1 by 2. Here we have 4 by 6, which will also multiply by 51. So here we have 4, 4 5 is 20, 6, 6 5 is 30. 204 by 306. So which is equivalent to 2 by 3. So now we can write 50 rational numbers between them. Is less than less than 155 by 306, and so on. This process continues up to 203 by 306, 204 by 306. So this 153 by 306 is equivalent to 1 by 2, and this 204 by 306 is equivalent to 2 by 3. And these are the rational numbers we have inserted between 1 by 2 and 2 by 3. So this way you will determine 50 rational numbers between two rational numbers. Can I do this? So what we have studied? We have studied about natural numbers, which is denoted by capital N. Okay, and we can write 1, 2, 3, 4 and so on. This is the set of natural numbers. Then we have studied about whole number, which is denoted by the letter W, and this starts from 0 and goes up to infinity. Then we have studied about integers. integers, which is denoted by either I or Z. And the set of integers are 0, natural numbers, and here we have negative of natural numbers. So this is the set of integers. Then we have studied about rational numbers. And rational numbers is denoted by Q. The letter Q comes from the word quotient. Okay, so quotient, the letter Q comes from the word quotient. Quotient Q is denoted for rational number. And rational number can be many. I will write here a few examples. Like 1 by 2, 2 by 3 by 4, 0 by 1, and so on. Many more are there, etc. We can write, etc. But the real number finished here? No, it's not. Real number are more beyond all this. We also have to study more numbers which are called real numbers. Okay. Now can I write this? Up to 500 before Christ era, it was believed that rational numbers are end of numbers. There are no any other number exist. But by the time 400 BC, it was observed that there are more numbers which are not rational number. As we all know, rational number are numbers which can be presented in the form of P by Q. But the numbers which cannot be presented in the form of P by Q, what they will be called? So they will be called irrational numbers. Okay, so how the irrational number came? We will learn about this. So, as we all have studied, real numbers are those numbers which can be presented on real number line. As we know, as we have learned, whole numbers, natural numbers, integers, rational numbers, all numbers are in real number line. As we all know, these all real numbers can also be presented in the form of decimal numbers. So, decimal numbers, today we will discuss how we can write decimal number and what are irrational numbers. So, let's see. The decimal number can be classified into two parts, terminating decimal and non-terminating decimal. Terminating and non-terminating decimal. Non-terminating decimal can further be classified into two parts, recurring decimal and non-recurring decimal. Recurring decimal and non-recurring decimal. So terminating decimal are those which can be terminated at some place. Okay, like 2.5, like 0.125, etc. It is terminated at some place. Non-terminating decimal which cannot be terminated. Okay, which cannot be terminated. In this we have two decimal like recurring and non-recurring. So some recurring decimals are like 1.333 and so on. Here we have 3 in recurring form. We can also write 1.3 to the power bar. Okay, so this is recurring decimal. Non-recurring decimal. Non-recurring decimal like 1.01, 001, 0001. So as we can see here, none of any number is repeating or recurring. That's why this is non-recurring decimal. And here we can see the numbers are in a pattern like 0.01, 001, 0001, and so on. So these decimals are called non-recurring decimal. So this can be denoted by Q. And recurring decimal can also be denoted by Q. But this non-recurring decimal is denoted by Q dash. As non-recurring and non-terminating decimals are known as irrational numbers. These are rational numbers, and these non-recurring and non-terminating decimals are known as irrational numbers, and we denote this irrational number with Q dash. These irrational numbers can also be written in the form of like root 2, root 3, root 5, and etc. These are called irrational numbers. Made of this, we can also represent real numbers in the form of chart. Okay, so here we have real numbers which I have presented in a diagram form. Okay, so as you can see, there are lots of infinity of rational numbers and irrational numbers. Okay, so here we have rational numbers and here we have irrational number. Rational number includes the natural number, whole number are also there, integers are there, and rational numbers are, all these are rational numbers. And here we have irrational numbers. I hope you all have understand. If you like the video, please like, share and subscribe to my channel so you will be easily notified about my upcoming videos. Thank you.